Hello, this is chapter 1 from Introduction to Computer, the Internet, and Java. In this chapter, we will talk about Introduction to Java Programming and Object Oriented Programming. So let's start with Introduction. Java is one of the world most widely used programming languages. So like 10 years ago it was number 1, but now Python is the most famous and still Java is very famous. You will learn to write instruction commanding computer to perform tasks. And actually this is the programs. Programming is how to write instruction to the computer using Java language. So the software is just instruction you write to control the hardware, which is the computers. You will learn object-oriented programming. This is today's key programming methodology. So all companies, all programmers are using this methodology to write programs. You will create and work with many software objects, as we will see. For many organizations, the preferred language for meeting their enterprise programming need is Java. So many companies actually they find Java the language that meet their requirement. Java is also widely used for implementing internet-based application and software for devices that communicate over a network. For example, the credit card reader is just a device that works on a network, but it needs some programming languages. So Java is used for that. According to Oracle, 97 of enterprise desktops, 89 of PC desktop, 3 billion devices, and 100% of all Blu-ray discs players, they run Java. And there are around over than 9 million Java developers in the world. So this is example of the devices that uses Java. So you can see it's airplane systems, they can use Java, Blu-ray discs players, credit cards, e-readers. So many things use Java. TV, ATMs, medical devices, robots, and many other devices they can also use Java. Not only the desktop, but desktop is also one of the devices that uses Java. Smartphones, smart televisions, and so on. Tablets, smart meters. So also like gaming devices, Sony, and so on. So in Java we have two editions. The standard edition, so actually this is what we will study in this course. Java standard edition contain all capabilities needed to develop desktop and server application. So we will study this, but there is Java Enterprise Edition. In Java Enterprise Edition, you will this will be used in a broad spectrum of application that it has two other edition. Java Enterprise Edition is geared toward developing large-scale distributed networks application and web-based application. And we also have like Java Micro Edition. This is like subset of standard edition. This is like uh, geared toward developing application for resource constrained embedded devices. For example, smartwatch, MP3 players, television set-top boxes, smart meters, and some devices like this. We can use for that Java Micro Edition. But in our course, we'll use the standard edition. So let's talk about object-oriented programming. So object, or more precisely the classes, objects, come from the essentially reusable software component. So there are data object, time object, audio object, video object, automobile object, people object. So we want to make programs that deal with these kind of objects. Almost any noun can be represented as a software object in terms of attributes. So any nouns can have some attributes, for example, name, color, size, and behavior. For example, calculating, moving, and communication. So this chapter is just introduction. I know many concepts will not be clear, but later in the chapter you will really understand what the meaning of these things. So software development group can be used as a modular, object-oriented design and implementation approach to be much more productive than earlier programming techniques. So previously in the previous courses we used structured programming technique, but now we want to use object-oriented programming techniques. So why we use object? Because it's often easier to understand, easier to correct, and easier to modify. So this is why we use object-oriented programming technology. We will give examples, real examples from our life to see how object-oriented relate to that example. Let's take like the automobile as an object. So the car, let's talk about the car in general. So let's begin with a simple analogy. Suppose that you want to drive a car and make it go faster by pressing accelerator pedal. Before you can drive a car, someone has to design it, right? So we need someone who designed the car. A car typically begins as engineering drawing, similar to the blueprint that describe the design of the house. So someone has to design that car and draw that car on a paper. This drawing includes the design of accelerator pedal. So he has also to design how the pedal look like. The pedal hides from the driver the complex mechanism that actually make the car go faster, just as the brake pedal hides the mechanism that slow the car, and the steering wheel hide the mechanism that turn the car left and right. So this is something similar to what we will have in object-oriented programming. So we will hide from you some details, and this hiding is very useful in programming. For example, if you want to print, usually if you want to print on the screen, there is a lot of things happening in the background, okay, but you don't care. You just write print or see out or whatever. So, but this is a method call or a function call, and there are a lot of details happening in the background, but you don't care what's happening. Same like when you press the accelerator in the car, there are a lot of things happening with the engine and gas and so on, but you don't care. You don't need to know the details. You just press and you expect the car to accelerate. Similar, we just write print and we are expecting to see the output on the screen. So this enable people with little or no knowledge of how engine, braking and steering mechanism work to drive the car easily. So this make our programming easier because you just need to write a print. You don't need to know all the details. If you want to deal with very complicated banking system, you just use the classes in a certain way. You don't need to know all the details of these complicated systems. So before you can drive a car, it must be built from engineering drawing that describe it. And this is similar to the classes what we will have. So we will have a class and then you have to create one object of that class, as we will see in this course. A completed car has an actual accelerator pedal and make it go faster, but even that is not enough. The car will not accelerate on its own, so the driver must press the pedal to accelerate the car. And the same, you need to write a print so that you can get the output. So method and classes. Performing a task in a program required a method. The method here is just like a function in C++ and in other languages. So the method houses the program statement that actually perform the tasks. And it also hides this statement from its user. So you don't see the details of the print method, for example. You just call it. Just the accelerator pedal of the car hides the driver mechanism from making the car go faster. In Java, we create a program unit called class. So we create a class in Java, and this class has a set of methods that perform some class tasks. we only need to use that methods. We don't need to know the implementation or the details of these methods. A class is similar in concept to the car engineering drawing, which house the design of accelerator, pedal, steering wheel, and so on. So the class, when you write a class in Java, it's like you design a car. And when you create object of that class, it's like when you create a car of that drawing, designing. So instantiation, just as someone has to build a car from its engineering drawings before you can actually drive the car, you must also build an object of the class before a program can perform the task that the class method defines. So an object then refer as instance of the class. So we write a class, and from that class we create object or instance from this class. Same like from drawing we create a car. So reuse, just as a car engineering drawing can be used many times to build many cars, you can reuse a class many times to build many objects. So you can have a design for the car. You can use that design many times to create many cars actually from the same design, many copies. Same thing, you create class one time and you create out of that many objects. So I create class student, and from that class student I can create a student A, student B, student C. I can create 1000 students from the same class. So this is called reusing. So reuse of existing class when building new classes and programs save time and effort. So reuse also helps you to build more reliable and effective systems because existing classes and components often have undergone extensive testing, debugging, and performance. So usually when you want to create a new car, you use the same design like before. Or when you want to create object, you use the same class. You don't want to make a different class for every object or a different design for every car. So that's why we reuse the same design. So, and this is very helpful actually in programming because we don't need to reinvent the wheel. We just use what other people did for us. So when you want to make programming, you just see if there is someone did this part, just use it. Don't do it yourself. We can reuse the code that other people did. So if I want to sort an array, I can look and see if someone has a method to sort the array and use that method. I don't need to do it myself from scratch. So this is important. And if there is such a code, most likely this code was tested and it's guaranteed to work correctly. But if you did the code yourself, you are in a risk of having some mistakes in it. So message and methods calls. When you drive a car, passing its gas pedal sends a message to the car to perform the task that it should go faster. In a similar way, you send a message to an object by a method call. If you send a method call, for example, if you call the method print, you send a signal to the class that you want to print this message, for example. So attributes and instance variable. A car has attributes, for example, the color, number of doors, amount of gas in its tanks, and so on. The car attributes are represented as a part of its design and its engineering diagrams. Every car maintains its own attributes, and each car knows how much gas it's in own gas tank, but not in the other car's tank. So I have many cars from the same class. So every car has attributes, like this car color is this. This car tank, the gas in the tank currently is like this. Every car knows how much tank in the car. This is the attribute of this car, but it can be different from the attribute of another car. So an object has attribute and it's carry along as it's used in the program. So as we mentioned before, the class can have methods and attributes or variables. So for example, a bank account object has the balance attribute. It has a balance variable that represents the amount of money in the account. Each bank account object knows the balance of the account it represents, but not the balance of other accounts. So every account has different balance, and the object has access to its balance, not the other object's balance. Attributes are specified by class instance variables. So encapsulation, this is also one concept of the object-oriented programming. Classes and their object encapsulate encases their attribute and methods. Objects may communicate with one another, but they are normally not allowed to know how other objects are implemented. So we hide the implementation details. So this is called information hiding. As we will see, it's crucial to good software engineering. There is also inheritance, where some classes inherit some are created by the inheritance of other classes. Okay, for example, in the car we have some kind of car, convertible. It's contained in an object which is more general class like automobile, but more specifically the roof can be raised or lowered. So there is a type of the cars, it has the same things from the general car, but it has special attributes which make it like a different type of classes, but it inherits a lot of details from the general class. So we'll have something similar in object-oriented programming. We also have something called interface, where the cars can do some functionalities. For example, how to open a radio. All the cars that has radios, there is should be mechanism how to open the radio. So this is something similar to interface. I know it's difficult to understand this concept from now, but I decided to just give you small introduction. So if you understand like 10% of object-oriented now, that's great. And once we have the 5 or 6 chapters talking about object-oriented programming, you will go back to this and you will understand it better. So let me skip this. Object-oriented analysis design. This is like when you want to write a program, first you need to collect something called requirement from the user or the customer. So you want to make a program for a pharmacy, you need to sit with the people from the pharmacy and ask them what you need for your program, which functionality you need. So after that, you need to design on a paper which classes you want to write, and you need to review your design before writing the code. So you need to analyze all the object-oriented analysis and design process, and you can write it then in any language that supports object-oriented programming like Java. We have some UML language where you can draw the classes on a paper. This is also you can use after you collect the requirement. Now let's talk about Java. So Java was designed in 1991. So microprocessor has a profound impact in intelligent consumer electronic devices. So because of the microprocessor, we start to have devices like small computers or something like this. Like for example, the credit card reader is considered a small computer, something like this. Or the computer in the car, you know. So in 1991, Sun Microsystems, this is a company, funded internal corporate research led by James Gosling, which result in a C++ based language. So Java is based on C++, and it's object-oriented programming, and the Sun decided to call it Java. And the key goal of the Java is to be able to work in any device, a great variety of devices. Not only like the desktop computers, but small devices. This is sometimes called write once, run everywhere. So in 1993, the web exploded in popularity. So we started to have internet and web, and some saw potential of using Java as a dynamic content for web pages. And then Java started to be very famous. Java drew the attention to the business community because of the phenomenal interest in the web. Java is used to develop large-scale enterprise applications to enhance the functionality of the web servers, to provide application for consumer devices, and for many other purposes. So the nice thing about Java, it has a great library of classes where we can use them. As we said, we can reuse the code, so we can use some already built classes, and we can use that. That in Python even much richer. So we should use Java API classes and method instead of writing them on our own, because as we said, the classes and methods in the Java library is already tested and it was proven to be correct. But if we wrote it ourselves, it will take more time and maybe there will be some mistakes. So this is the typical Java development environment. So first we will do edit, compile, load, verify, and execute. Okay, so let me go very fast on these details because we will see them later. So phase one, we will need to write the code. This code is called source code, and once we save it, it will be .java. So when we write a program, it will be the name of the program .java extension. So after we edit, we save it as a .java file, and after that we need we can use IDE to see the error. Okay, so we can use editor, but it's better to use IDEs, like the popular IDEs like Eclipse, NetBeans, IntelliJ, so many other IDEs you can use here. And after that you need to do some compile, Java compile. So Java compile will convert the source code into .class code. This .class code is called bytecode. Okay, so when you compile the code, if it was correct, it will be stored as .class, and this .class is called bytecode, and there will be something like Java virtual machine. The Java virtual machine will read this code and try to execute it. That's why Java virtual machine can work in all computers or all devices or types of devices. That makes the Java cross-platform. So that's why we said bytecode is portable. It can work in every device. Every device that has a Java virtual machine can run this code. So you write it once, the code, run it everywhere. You can run it in a computer. You can run the program in a credit card reader. You can run this in a smart television and so on. The Java virtual machine is invoked by Java command. For example, execute the Java application called welcome. You would type the command Java welcome. So the Java virtual machine will run it, and then you will load the class after that on the memory. So you will load the class in the memory and the computer will execute this code. So the computer starts to execute this code, and it uses something just-in-time compilation, and then the program will run. So this was just introduction about Java and about object-oriented programming. I'm not expecting that you understand everything, but as I said, if you understand 10%, that's fine as a start. At the end of the course, you will understand exactly with examples all these concepts. Thank you very much and see you in the next chapter.